we have rental income from a home comes into the owner of the property at a rate of $60,000 a year. So this homeowner is renting this property for $60,000 a year. Now there's a long-term indefinite lease. So I'm going to read that as the time is going to infinity. On the property, and the property owner immediately invests the income into an account paying 4% interest compounded continuously. Find the present value. All right, so find the present value. So down here, here's our formulas for future value and present value. So we're looking for present value of this income stream. Let's start by writing our formula. We'll have the present value is equal to the integral from 0 to t. Now that t, that's the end of our time limit, right? And we're going to infinity. So this is going to be an improper integral of f of t e to the negative rt dt. So we're looking for this. We want the present value of 0 to infinity of, now it comes in at what, $60,000 a year. Well, $60,000 a year. E to the negative, now we're getting this at 4%, 0.04t dt. Now, it's an improper integral, so we know what to do here. The present value is going to be the limit as b goes to infinity of the integral 0 to b of 60,000 e to the negative 0.04t dt. This is going to give us the limit as b goes to infinity of, so what do we get here? This is going to be 60,000 e to the negative 0.04t, now we're integrating, so it's divided by that 0.04 from 0 to b. So to make computations a little bit easier, since the 60,000 and the negative 0.04 are constants, I'm going to bring this outside of the limit. You got to remember all the way back to our chapter on limits. I can take that out, so I'm going to get 60,000 divided by negative 0.04. We could go ahead and divide if you like, but then I'm going to get the limit as b goes to infinity of e to the negative 0.04t from 0 to b. Now I'm going to go ahead and divide. 60,000 divided by negative 0.04 is negative 1.5 million. And then we're going to have the limit as b goes to infinity of e to the negative 0.04t from 0 to b. So this is going to give us negative 1,500,000. Now, this is going to be the limit of e to the negative 0.04b, actually all of this, right? The limit of put in the upper exponent minus the lower exponent. Now, if you put in that lower exponent, you get a 0, right? So it's e to the negative 0.04 times 0, which means that in the long run, at $60,000 a year, if it just keeps on going forever, this is going to come out to, that $60,000 a year is going to make us $1.5 million.